Hey everybody, in this video we are going to talk about how to find the volume of any kind of prism. Now I have kind of already set up this page because there is some three-dimensional drawing when we're talking about the volume of something because we're working now with the three-dimensional shape. So if you want to pause this video and copy the first part of what you see down and then once you unpause it, I'm going to move the camera down so you can copy. There's two more shapes beneath the rectangular and triangular here. So take a moment, pause the video, copy this down, and then when you unpause, I'm going to move the camera down so you can copy the bottom part. So go ahead and take a moment. Okay, so if you have copied this top part down, now you can copy the bottom part. So if you want to go ahead and take a moment and make sure you have these drawings, you will notice in these videos that I am not the best at three-dimensional drawing, even after years and years and years of teaching math and drawing three-dimensional shapes. I can never get better at it. So make sure all of these drawings are copied, pause the video, and when you are done, when you unpause, we're going to start talking about how to find the volume of these different kinds of three-dimensional shapes. Okay, so to start off by talking about the volume of prisms, there's a couple of things that we need to discuss. The first thing we're going to discuss is what is a prism, okay? So a prism is a three-dimensional figure, obviously, that has a base shape. And you'll notice, if you haven't already kind of seen from the videos, the base shape could be all the different kinds of two-dimensional shapes that we work with. But it has parallelograms for sides. So I'm just going to put has parallelogram, and I'm pretty sure I threw an extra R in there for parallelogram sides. Usually they're rectangles. But sometimes we have parallelogram sides that don't have right angles, so they're not technically rectangles. So that's why we say, instead of saying that has rectangles for sides, we say parallelogram sides. But most of the time it's rectangles. And so prisms look like kind of all these shapes that you've already copied down. When we have something that kind of looks like a box or a cube, that is a prism. Its base shape is either a square or a rectangle. If we have something that kind of looks like a tent, or if you have ever had that like Toblerone candy, something that comes in that kind of shape, that is what's called a triangular prism. There are other kinds of prisms. If the base shape is a trapezoid, we call that a trapezoidal prism. And then this is technically its own thing, but I kind of like to include it in the prism category because we find the volume of a cylinder in the same way that we find the volume of the other things you'll see in a moment. But a cylinder has a base shape of a circle, and instead of the sides being kind of like their own rectangles, essentially in a cylinder, what happens, it's like a giant rectangle wrapped around the circumference of a circle. When we talk about surface area, this will be a lot more apparent. We'll draw something called a net, or you may have drawn a cylinder net before, or you've had to construct one out of paper and you kind of know what I'm talking about already. But if you don't, or when we talk about surface area, we'll get to that. So the way we find the volume of any prism, including a circular prism, is, let me move my light. I'm trying to get better lighting for my YouTube videos because I'm so famous now with like my 115 subscribers. Thank all of you guys. But so the way we find the volume of any prism is we take the area of the base shape. So we take the area of base shape, okay? And the base shape could be kind of right in the front. We could think about it as like the front shape and the back shape of a figure. So like in the triangular prism, the front shape's a triangle, the back shape's a triangle. But if I like flipped this triangular prism kind of like on its side, you could think about it as like the top or bottom of a figure. Essentially, whatever shape is not necessarily the rectangle, the rectangular or parallelogram sides, like that's the base shape, except for when you have like a rectangular or a rectangular prism or a cube. Like obviously like the base shape is all kind of the same it's the same as the sides. So we take the area of the base shape, whatever that formula is. So we've learned all the formulas for area of two-dimensional shapes. So we take that and we multiply it times the height of the prism. So we're going to take the area of the base shape times the height of the prism. And we typically say the height of the prism because in some of our two-dimensional shapes, we have like the height of the shape. So for example, in a triangle, we're gonna have like the height of the triangle, but then we also have like the height of the prism. So we typically use a capital letter H to define the difference between height of the prism and then like height in whatever the base shape is. So that way you don't get the numbers confused when you plug it into the different formulas. So all we need to do is just kind of now distinguish what the area of all our different base shapes are. So you can see how this is like the same formula, but the only difference is we're going to be plugging in a different formula for area of the base shape, because depending on the base shape, we use a different formula for area. So we'll do rectangular and triangular first. In a rectangular prism or a cube, which is a prism that has all sides that are squares, kind of like a Rubik's Cube that a lot of you guys like to play with, we have our height of the prism. So in this case, because my prism's kind of tipped over on its side, the height is kind of like the longest part of it. Then we have our length and our width of our rectangle. Sometimes people say base and height of a square or rectangle. Those are kind of used interchangeably. I like to use length and width because base and height comes into play in other shapes and it can kind of be confusing. So to find the volume, we're going to take the area of the base shape. So to find the area of a rectangle, we do length times width. And then to find the volume, we're just going to multiply it times the height of the prism. So this is one that a lot of you probably already know. Length times width times height is how we find the volume of a rectangular prism or a cube. Triangular prism, the area of the base shape is all about the area of a triangle. So in a triangle, we have a height of a triangle. So I'm going to use a lowercase letter h. We also have a base of a triangle. And then this longer part over here, this is like the height of the prism. If I kind of tipped this triangular prism on its side. So to find the volume for a triangular prism, we're going to take the area of the base shape. So if the base shape is a triangle, the area of a triangle is 1/2 base times height. And we are going to multiply all of that times the height of the prism to find the volume of our triangular prism. So it's the area of the base shape times the height. Very similar over here, area of the base shape times the height. So let's look at the last two. You can pause right now if you want to see if you can kind of guess or figure out what the formula is. If you remember what the area for a trapezoid is, if you remember the formula for area of a circle, you can pause it and see if you can come up with the formula. For a trapezoid, we have our bases, and then we have our height of our trapezoid, and then we also have the height of the entire prism. So to find the area of a trapezoid, we take 1/2 the sum of our bases, so base 1 plus base 2. It doesn't matter which base is base 1 or which one's base 2. When you add them in either order, you get the same thing, times the height of our trapezoid. And then we have to take this whole thing. So I'm going to actually use brackets here. We're going to take the whole thing and then multiply it times the height of the prism. So it's the area of a trapezoid times the height of a prism. So it looks a little crazy, but that's basically what it boils down to. A cylinder, it's the same thing. We're going to take the area of our base shape, which in this case is a circle, and multiply it by the height of the prism. So the prism is this height. In the circle, we're either going to need the diameter, or down here, I'll kind of label the radius. When we take the area of a circle, we need the radius. So the formula to find the volume of a cylinder is pi r squared, because that's the area of a circle, times the height of the cylinder. So we take the area of the circle times the height of the cylinder to find the volume. So in all of these cases, all we did was take the area of the base shape, which is either like, you could think about it as like the front and back of the shape, or like top and bottom, depending on how the shape is like orientated. So yeah, area of the base shape times the height. So make sure you have all these formulas down, and when you work on your practice problems or your homework, just make sure you look at the kind of prism and then you use the appropriate formula, and make sure I would label on your pictures what is each part, so that way when you go plug it in, you make sure you're plugging in the right number where it goes, because a lot of times people confuse the heights, and that doesn't always mess up your problem, but it could. So it's important, especially with like if there's multiple heights, like the height of a trapezoid and the height of the prism, or height of a triangle and height of a prism, you appropriately label them on your picture. So when you go plug them in, you plug them into the right spot. Check out the next video in the playlist. Have a good day.